Hello everyone and welcome to our RAN 3D webcast with Yuri Apavanich. He will cover the key functionality today of the CATIA DM1 viewer tools. So Yuri, pass things over to you.
Okay. Good afternoon everyone, or good morning to those attending from the West Coast and Central Time Zone. Today we're going to discuss and I'll show you a few things about a tool called Inertia DMU Viewer, also known as DM1 Viewer. The webcast topics, what is Inertia DMU, how it compares with CATIA, what's the value proposition, we'll do a lengthy live demo, should take about 20 minutes, then we'll wrap things up by doing a summary and a Q&A session. So the DMU Viewer, it's also known as DM1 Viewer. It's a part of the SOS Systems family of PLM solutions, as most of you know. And what it does, it enables companies to view, interrogate, and understand all the information embedded in native CATIA files. So you don't need to do any translation, conversion into step, etc., etc. And Inertia DM1 is the recommended solution for the supply chain companies that have a build-to-print relationship with the OEMs or need to look at CATIA data for the request of proposal purposes. So the point, instead of buying or paying for a full-blown CATIA license, a lot more expensive, you just buy a view portion, and this way you can actually interrogate and get all the necessary data from the files your supplier or your OEM will send you, and it's the least expensive entry point into CATIA V5 data. Neutral CAD format. So you might say, okay, what if I ask my OEM to simply output or export the model into IGES or STEP and go from there? Well, STEP and IGES, they only store the geometrical shape and size of the model, and all other critical design information is lost when this station happens. So information includes 3D dimensions, tolerances, annotations, nodes, material specifications, manufacturing specification, and the list goes on and on and on. So if your OEM requires you to be able to view that information, etc., perhaps your only solution is using DMU Viewer. So you got to remember the limitations. The Inertia DM1 is a powerful viewing tool, but it is not a design software. It doesn't have the ability to edit the CATIA geometry, and neither it has the ability to export to STEP or IGES in order to transfer the geometry to other design or manufacturing tools. So in other words, if you're given a model by your OEM or your customer, you can only open it and view it. You cannot change it. You need to edit the design data or to translate the data for use in other CAD system. Then you will require a full CATIA V5 software and license. So that's kind of the major limitation. The upside, it's a very low-cost entry point into CATIA world. So what are you going to do during demonstration? I'm going to go over very typical tasks that majority of suppliers need to perform, which is opening and viewing part, product, and drawing files, or reviewing 3D dimensions, GD&T, and other annotations, taking all kinds of measurements, distance, lengths, area, volume, and mass, creating cross-sections, exploded views, also adding annotations for internal use, and also capturing screenshots and printing, etc., etc. So I'll jump into a live demo, and what you're going to be seeing on my screen in just a minute. Okay, I'll open it up and explode. That's the DMU Navigator V5 without any files open. If you want to work with a single part instead of assemblies, you got to start by creating a new product. Hit product, hit, and that's a new product. So if I want to see a 3D part, I can right-click, commands, and insert existing component. That's part. Again, I'm going to pick this one. Okay, data, loads, etc. So basically, it has the standard CATIA functionality as far as navigation, etc. We can fit all in, we can in and out, etc., etc. rotate using compass. There are some standard views just as well. For instance, if you want to see the isometric view, that would be this one. If you want to see the front view, that would be this one. If you want to see the top view, that would be also render in different ways. This is so-called shading with edges. There are other methods. Pretty much standard CATIA stuff. For instance, if I want to see the wireframe rendering of the model, if I want to see rendering with materials, so as aluminum applied, so it shows a nice and shiny reflections, etc., etc. You can also create saved views, and that's very convenient. Let's say along your, during your work, you will have to frequently look at, say, this location in the model. So what you can do, you can go into the named views, and add a new one. You can pick any one you want to apply. So now if you want to go back to that specific view very quickly and efficiently, you see it shows so-called camera. That's a saved view. You're going to go in here, pick the one you want to use, hit apply, and it's just ready. So pretty much standard CATIA. So as far as viewing and navigation of the model, there is no difference between this tool and the standard CATIA. Get rid of this save view for now. What else? Well, typically if you work with many OEMs, they will send you so-called GD&T information, notes, etc., and you won't be able to see them. Let's switch to a different workbench. In a digital mockup, you see there is a DMU tolerance and review. Okay. And if I click that, okay, so there's a whole lot of all kinds of GD&T and annotations and dimensions, etc., etc. If you take a closer look in the tree, a so-called annotation set is a bunch of views, datums, reference frames, geometrical tolerances. You want to locate a specific item. Let's say I want to find this symbol flatness.1. Right-click, refresh on, and right there. Okay, I can go back and forth. And visualize by views. Let's say I want to take a look at a specific view. Let's say I want to see the front view. Hit the front, there you go. What you might want to do is filter those annotations. And the way how it's done, CATIA uses the concept of captures. Capture is like a specific consideration, including the viewpoint for the annotations. So this will happen to have a few captures. All annotations, front, top, display capture, not only display annotations related to that capture. There's no unnecessary annotation, etc. If I would take a look at the top annotation, we play capture, and there you go. These are all GD&T symbols, etc., etc. And you see the general note capture, display capture, so the general notes. Okay, so what else you want to do is perhaps capture those images. And let's say I'm going to capture the front, or display capture, which is the front view. And I want to capture this view and maybe print it for external use. So you can go Tools, and there's an option Capture. It's not actually Snag It or Windows Snippet or anything. It's actually much better too. So there are several capture modes such as pixel, vector, etc. And what I want to capture is, let's say, this area. Okay. If I hit record, it shows the preview, and it shows me white background, and I can print it. I copy and then paste it into a Microsoft Office application, and I can also save it to an album. Now, there are also some settings over there. For instance, you go into the settings, okay, and in the pixel, you see I've selected white background. If I unselect white background and hit OK, if I do recording, that would be with the background. Actually, what I want to do is to be able to print it. So therefore, I'm going to use a white background. I'm going to go pixel, background, If you go, hit recording, and that's it. So as I said, I can save it to JPEG. So if I hit save, go save it, let's say, as capture JPEG, and I can pick format. So that's JPEG, let's say, high quality. It's okay. Okay, take a look at the folder. Okay, the capture. So they're JPEG, or you can print it just as well. So for instance, if you want to print it, print in options. So instead of you printing to a printer, I'm going to use print to Adobe PDF. So as you see, I can use no fitting, fit page, or fit to specific size. There are a bunch of options for page setup, options, etc., etc. So now hit apply. Okay, ask me where to save this PDF file. PDF creator. Slow. Yeah, it's done. So you see we're looking at the PDF file. At this point, I can send this information like captures and images, etc., to other departments, to maybe cost estimates or prepare for manufacturing, whatever that is. Okay, I'm going to cancel this, close that up, and close that up. If you want to do the measurements, so I'm going to hide this for now. Sometimes you might want to do measurements on the go. So for instance, what I want to find out is the diameter of this hole. Okay, switch to the navigator workbench, navigator, and the measuring tool. So an item I can measure between. So I want to measure an item. Let's say I want to know the diameter of this hole. Surface, and tells me radius is 3.962 millimeters. Surface area. It can be customized. For hit customize, as you see, I can request all kinds of different information. First, I could always request the center of gravity, perimeter, if it was a volume, area, and stuff like that. So at this point, we can move this away a little bit and hit OK. Now, I want to do measurements between. Let's say what I want to do is to find out the distance between the center of the central hole and those guys. So hit measure between. Okay, measurement between. See, by default, it picks the axis of this hole. Another one. The distance, as you see, it is 34.925 millimeters. And okay. So the measurements are stored in the tree because I selected the option key measure. So it's those things. If I want to hide them, for instance, if I want to do a screen grab or something, right-click, hide and show, right-click, hide and show. And ultimately, if I don't need those measures, just delete. Right-click, delete, right-click, delete. You can measure inertia, and let's try this one. So I'm going to measure inertia. And what I want to do is measure this part. So it tells me the volume if I want to know the volume of this part. Area, for instance, if I wanted to figure out the cost of plating of the part or maybe painting and stuff like that, it shows me the mass. The density is obtained from the material specification. As you see, there is a material over there. We'll get there in just a little bit. It can be customized. So if I want a bit more information about this part, I want to know the principal moments of inertia. If it was a rotating part and I wanted to balance it, perhaps, there it shows me principal moments of inertia, and so on and so forth. So specifications, if your OEM provides material specification that sits right there in the tree, you can always verify it. Click. Okay. So in this dialog box, and if I go into the analysis, these are the properties you see. It's Young's modulus, material density, thermal expansion, etc., etc. So you can be well prepared to prepare manufacturing process. So that's about parts. You can also open assemblies and drawings. So let's do a couple of things with assemblies. close, and I'll open. Now it's going to be a product. Okay, with measurements with assembly, same tools, absolutely same tools. If you go to Digital Mockup Navigator, already, so same tools as far as measurements, etc., etc. No difference. But we want to do something different. We want to do perhaps a cross-section. Okay. Tool for creating a cross-section. I'm going to section, and it shows me a couple of windows. I'm going to tile them, tile vertically. So the actual cross-section, and that's the plane. So you move the cutting plane, the cross-section plane. You notice on the left side it changes. Okay, we can take the plane, etc. We can place the plane exactly. For instance, if I want to snap this plane to this surface, you would select geometrical target, click plane, and it's snapped. If I go to result, I can also view it as volume cut. Okay, shows me the cross section, and on the right side this. So now let me move this plane a little bit, and I'm gonna move the one in, and turns out actually I detected the interference. So that's bad design, which may happen. Sometimes you're given drawings by your OEMs which are not exactly perfect. So see, there is a little bit of interference between those parts. Okay, what I'm going to do is to create an annotated view. So okay, this is stored in the view. Okay, cross section. You see, it says application sections in the view. And what I want to do is create an annotated view. Okay, many ways to annotate, and I'll use so-called 2D annotation. That would be this guy, annotated view. Okay, so it pops up. It's called DMU 2D marker. It's kind of similar to Microsoft Paint tool. You can draw a line, draw a freehand line, circle, etc., etc. I'm going to draw a freehand line, and I'll draw something like that. Okay, like the way how it looks, I can always hit properties. I want it, let's say, a little thinner, and I can set the thickness to, you know, maybe thinner one, like, and I add the text. So to write down here, it says text it in this area. Okay. Hit OK. I'll create also a line. At this point, I can exit this 2D annotated view workbench, and when I send it to other guys in the group that have the same tool, I can easily go and see it. So if I double-click on this, I can actually zoom it out, but when I double-click on this 2D annotated view, it pops up and shows me all annotations, etc. So that's another way of communicating, you know, your ideas and findings between the members of your group. And that's one of the tasks. Let me show you another task. And what I'll try to do is to create exploded view, which is also very useful for the shop floor guys, etc., etc. So I'm going to hide the cross section, and I want to create an exploded view. Exploded view, you use what is called scenes, enhanced scenes. Enhanced scene is like a temporary configuration for an assembly. And I'm going to click that. Instead of using name, I'll create a first created scene, which will be all parts, which lets me bring the parts together after I do the explode. Hit OK. And so basically, this all part scene is needed for me to be able to get it done, to bring them back together. Now I'm creating an exploded view. I'm going to create another annotated, another scene. Be explode. Okay, hit OK, and reload tool. So explode. If I apply, they all go apart. Okay, so if I move the slider, they kind of explode. there was a sub-assembly, a main assembly, so it unexploded the main assembly first and then other parts. So okay, I can still adjust location of my part using a compass. Let's say I like this exploded view very much, I like to maybe modify it. So I can move this up a little and move it this way a little, so pretty much adjust the way you like it. Okay, and when done, I can also hide and show components in the scene, what I want to do. All right, so if I want to get the exploded view to maybe make a screen grab or something, I can right-click, exploded object, apply scene on assembly, apply the entire scene, and there you go. That's my exploded view. So again, I can make a screen grab at this point, print it out, anything I want to do. And if I want to bring the parts back, click the all parts scene, all object, apply an assembly, and it's back. Okay. And the last little topic we'll discuss, sometimes you get two-dimensional drawings, like blueprints essentially from your customers and OEMs, and this tool also lets you open and use those. Just open a simple drawing. Okay, so here you see there is a drawing. It has mentioned CAD drawing. It's a native CAD file. Okay, and there's a drawing. So as you see, one actually shows a whole bunch of views for the model I was looking at. So this tool, I can also open the XF file, AutoCAD file, DWG. I can also work with PDF files and many other options. So I examine, the dimensions. For instance, I wanted to know the cross-section of this T-bar, etc. So there you go. That's how it was given to me by my customer. And to examine maybe other area, that's it. You can also make a couple of things here, like temporary measurements. These are so-called 2D measurements. These are done on a pixel level. They're not very accurate, but I'll show you a couple of things. So first of all, you calibrate. And you calibrate by using the known distance. So I'm going to hit 2 measurement. Okay, and as far as calibration, just pick 2 points. Let's say I know the distance between those 2 lines. It's 781.05. So I carefully select this, carefully select this, and say, well, the distance is 7.05. Okay, switch to measure. It's going to use this calibration to any kind of measurement I want to do. So for instance, if I want to determine the distance from to line, it gives distance. Entirely accurate, well, it's not as accurate as you would measure on 3D, but nevertheless, you can get a good estimate of maybe measurements and distances and lengths on a 2D drawing. Just to summarize what we've learned, I'm going to go back to the slide. The summary. So just to remind you, Inertia DMU is the tool designed for viewing and interrogating of native CAD 5 files. It's not a design tool. If you edit, update geometry, etc., it's not enabled. However, it has its value proposition. It enables viewing and examination of all native CAD 5 data with a translation to a neutral format, and it's also inexpensive. It's best suited for the build-to-print jobs and for responding to requests for proper